it just lends itself to being swapped, you know. But LS is like the hottest engine in the world right now. I mean, they pretty much are like swapping it into Jeeps and the Miatas and you name it. But the architecture is really hot. I mean, everybody has an LS.
At the end of the day, we learned the simplicity and affordability of LS engines are huge advantages. A factory performance LSX block, readily available aftermarket cylinder heads, and a proven track record speak for themselves.
So on our late model high-tech stuff, we talk about 4 valves per cylinder, and that's high revving, high tech, huge horsepower, all that stuff. Mate, this thing's got a single camshaft and it's got 2 valves per cylinder, and it's got push rods, and it makes bulk horsepower. It just goes to show you don't need to reinvent everything. This thing works.
At the 1997 North American International Auto Show in Detroit, Michigan, Chevrolet revealed to the world the most advanced Corvette produced to date. The C5 generation of the Corvette brought a legion of upgrades over the outgoing C4. But arguably, it was the changes under the fiberglass hood that would forever impact car enthusiasts worldwide. Powering the C5 Corvette was the LS1, a clean sheet design only sharing 2 parts from the previous Gen 2 small block Chevy engines. The 3rd generation small block Chevy was a thoroughly modernized engine, featuring deep side skirts, cross-bolted 6-bolt main bearing caps, and a composite intake manifold, among many other advancements. Most surprising though, the LS still retained a cam-in-block pushrod design first introduced in 1955. Despite being considered technologically archaic, the LS family of engines have won the grueling 24 Hours of Le Mans 7 times and has spawned almost 40 different variants, cementing this engine's legacy on and off the track.
All right, I'm back. And before we get going, I just wanted to point out that this video is actually just a remake of the very first video that I made on this channel. So for those of you who have been around since the very beginning, this might seem a little familiar to you, but I'm going to explain why at the end of the video. But for now, let's just get straight into it. Because when General Motors released a 3rd generation small block Chevy, a lot of people felt that the LS was more evolutionary than revolutionary. After all, the LS and its predecessor, the 2nd gen, or the LT1, shares a lot of design elements. Both engines have the same displacement, same bore spacing, and both are cam and block or overhead valve pushrod style engines. But if you were thinking that the LS was just simply prehistoric technology that was slightly warmed over, you're dead wrong. And yeah, when you compare the LS with things like the Coyote, it's clearly obvious that GM chose a completely different route of power production. Now, traditionally when designing the valve train on a high-performance engine, what you will typically see is a bias towards dual overhead cam setups. Engines like the Ford Coyote and the Honda K-Series are perfect examples of this. Now, the justification for this preference usually comes down to 2 main reasons. 1, peak airflow potential, and 2, valve train stability. When it comes to peak airflow potential, the surface area of the intake valves is directly translated to the ability to be able to move air inside the engine. So even though the individual valves of a 2-valve head like the LS are physically larger than the valves of a 4-valve head, the 4-valve heads have more intake surface area. The second reason why pushrod engines have kind of fallen to the wayside when it comes to high-performance engines is valve train stability. When it comes to high RPM performance, the major thing that you want to avoid is valve flow. The biggest way that you combat valve flow is by, well, just using stronger valve springs. The valve spring is the only part of the valve train that returns the valve back to its seat. But things kind of get complicated with pushrod engines because there are a lot of moving parts in the valve train, and all of these parts carry their own inertia and potential energy, and the valve springs have to fight against this in order to close the valves and keep them closed.
We were talking about push rods, and you were saying weight isn't really the thing, it's stiffness.
Oh yeah, because of the push rod flexes. I like to call the push rod going boing,
Right.
and it's just pole vaulting the valve, and you're out of control at that point anyway. So stiffness of the push rod is very important, more important than weight, I would.
Now, GM knew this when designing the LS, and that's why they assembled a team of drag racers and NASCAR legends to come together to mitigate the drawbacks and compromises of the pushrod design. And with the engineering expertise that GM assembled, they came up with a valve train design that can move as much, if not more, air than a dual overhead cam engine. And then on top of that, they designed a valve train that was stable up to 7,000 RPM. GM choosing to innovate and engineer around the typical issues of a pushrod design gives the LS one of its major advantages: its size. Despite having a large bore spacing pattern and offering huge displacement options, the LS is actually a very physically small engine. When you compare the LS to its big rival, the Coyote, it looks absolutely tiny. And this sizing advantage of the LS is, well, no pun intended, a huge advantage. From a chassis design perspective, it allowed GM to engineer cars like the C5 and the C6 Corvette. Both of these cars have incredibly low centers of gravity, and that's a major reason why Corvettes have been so dominant when it comes to racing. The LS's size advantage also helps you if you are working on an engine swap yourself, because the LS is nearly the same size as a turbo 4-cylinder, and well, if you're like me and you come from the world of BMWs, the LS is significantly smaller than an inline 6. That's a big reason why a lot of people swap LS's into BMWs, because, well, obviously you do unlock more horsepower potential, but then you also improve the chassis dynamics by moving to a more compact engine. GM didn't just spend all of their development dollars on the valve train though. The bottom end of this engine is an engineering masterpiece. The LS's block is a semi-closed deck design. It has a very deep skirt, or what some people might call a Y block, and thanks to this design, the LS has 6 bolt main caps. The LS has a 4.4-inch bore spacing, forged crankshaft, and some models even came with titanium connecting rods. In terms of block construction, there are 2 main options: cast iron and cast aluminum. The castings of these blocks are identical, and thus all the parts are interchangeable. The big advantage of the aluminum block is weight savings. The aluminum variants of LSs tend to be around 90 to 100 pounds lighter than iron blocks. Aluminum also has better heat dissipation properties than cast iron. The known power limits for an unopened aluminum block LS is in the 700 to 900 horsepower range, depending on the displacement. Now, when it comes to the cast iron block engines, there's really 2 big main advantages. 1, it's cheaper, and then 2, it's stronger. Due to this increased strength, iron block LSs can push horsepower limits near 1,000 horsepower. But like I said, you do take a weight penalty for selecting an iron block.
Yeah, iron and aluminum is all they've made them out of. The pros and cons of aluminum, I think, what I've always found is that anytime I do an aluminum engine block, obviously you get a weight savings. I think it's almost 100 pounds on an LS. The iron LSs are just monsters, you know. The big advantage of an aluminum motor to me is that they always tend to cool better. They, you know, take that heat and they get the heat out of the coolant. So for whatever reason, you know, when you get into real high performance cars, you're almost always taxing the coolant, so you need a big radiator, but you usually borderline on whether you can cool that car or not. When you go to an aluminum block, I'll usually see 15 to 20 degrees that it eases up on the cooling system. You know, the big pro with iron is it's just burly, you know, it's strong. So, you know, if I'm going to do like a heavy hitter street engine or something, I usually like to have iron in there because you can just, you know, it doesn't move as much as aluminum. I mean, they're both cast. You can break aluminum cast and break cast iron. You can tell how much stronger iron normally is. So, you know, your big pro with iron is that it's strong. Another pro is that it's cheap.
But regardless of if you select an iron or aluminum block LS, the key takeaway is that these engines are very stout and robust in their design. And that's a major contributor to the LS's track record of reliability. The LS is generally regarded as a reliable engine, but it does have some problems or issues that you may encounter in your ownership experience. The major issue that you'll see with LS engines is related to DOD and AFM, or displacement on demand and active fuel management respectively. Both of these technologies were designed to save fuel, but at the end of the day, they've proven to be problematic for the long-term reliability of this engine. Now, the thing about DOD and AFM is that not all LS engines have them. All LSs that are in the Gen 3 family and all true LSs, so LS1, LS2, LS3, basically all of those engines do not have these technologies. But if you're a car enthusiast that's out there looking for one of these engines, there's actually a sizable chance that you will find a Gen 4 engine that has these technologies installed, and it will need to be deleted. Other common issues that you might experience with the LS include the factory oil pump cavitating above 6,000 RPM, the LS7 had a nasty habit of dropping valves inside the engine, valve train components wearing out and chewing up the camshaft, leaky intake manifold gaskets, faulty knock sensors, oil leaks, and issues with low oil pressure. But kinda like I said in the Coyote video, just because these issues can happen to your engine doesn't mean that all of these things will definitely happen if you buy an LS. From a car enthusiast point of view, I think your biggest concern with the LS is DOD. And it's kinda to the point where I feel that I can make a universal recommendation for LS maintenance here. If you're a car guy and you're buying an LS to do performance stuff, my biggest recommendation is to just plan on doing a DOD delete kit, and then also while you're in there, upgrade the oil pump. I'm going to leave a link in the description for all the parts that you need to do this job, because if it were me, I would just want to get this knocked out and not have to worry about it anymore. I'm also going to leave a link in the description of all the parts I use on my LSs, not just AFM and DOD delete stuff, but all the parts I use on my LSs, because all the stuff on that list probably will come in handy, because if you live in the United States, without a shadow of a doubt, the LS is the single most accessible engine for any car enthusiast in the United States. The LS came in a large variety of GM performance cars, so we're talking about cars like the Camaro, Corvette, CTS-V, GTO, and the G8. If you want a sports car that's powered by a LS from the factory, there are tons of options for you out there. But surprisingly, that's not really where the LS truly shines. The LS's strong suit is its ability to be swapped into basically any car that has ever existed. Now, when you're searching for an engine to swap, halo engines like the LS7 or the LS9, you're almost never going to find those engines outside of the cars that they originally came in. But if you are willing to lower your expectations to a more realistic level, then the LS really begins to show its strengths in the availability category. At the end of the day, if your project car needs a new power plant, a 5.3 LS is going to be super accessible. If we're just going to be real, every single winter there's a whole bunch of hillbillies with 5.3 Silverados that wanted to show their buddy something super cool and power split it into a pole. It's just way too easy to find one of these engines because GM literally built millions of them in pickup trucks.
Not if I have anything to say about it, and I do.
Alright, so we kind of need to address what I mean by the term LS, because I'm sure there's a whole bunch of people who are already brigading me in the comments. Now, every now and then, when I talk to somebody in real life about the LS swap that I'm doing on one of my BMWs, I occasionally get confronted by people who usually throw this idea at me that,
"Hey bro, that engine that you pulled from the junkyard's not a real LS, it's a Vortex engine, and I hope somebody comes and kicks you in the dong, and you learn to not call Vortex LS's, you little piece of..."
And the reality is, at the end of the day, officially the engines that we call the LS engines, according to GM's technical literature, these engines are officially called the Generation 3 small block Chevy engine and the Generation 4 small block Chevy engine. Now, from what I've researched, a lot of the confusion around the naming actually comes from the car community itself. Since the beginning of time, the car community has had this habit of giving car parts and even complete engines nicknames, and the small block Chevy is one of the most common examples of this. Engines in the Generation 1 and 2 of the small block Chevy family have most notably been nicknamed by either their displacement or their RPO codes. So it's not uncommon to hear older car enthusiasts say that their Camaro has a 350 or a 454 in it. You may also occasionally hear somebody say that their engine has something called an LT1 in it. Now, those 3-digit codes are what is called an RPO code, and every option on a GM vehicle has an RPO code, or a regular production option code. Now, this complete list of codes, or this entire matrix of codes, is what the dealership and the factory use to build the exact spec of car that you have. And like I said, every option on the car has an RPO code, including the engine. Now, RPO codes in GM's viewpoint aren't really viewed as that special, and the evidence of that is, well, GM reuses them, like, all the time. A great example of this is the LT1 RPO code. It was first used in 1970 on the Generation 1 small block, and then they reused it again in 1992, and then for a third time in 2013. When the C5 Corvette debuted in 1997, the RPO code for that first Gen 3 small block was, well, LS1. And then the RPO code for the second one was LS6. And from that point on, the car community latched on to that name just forever and started calling all of these engines LS engines. But the interesting thing is, from a marketing standpoint, GM actually branded most of these engines as Vortex engines. And despite what people tell you in the LS community, Vortec engines were not just for the trucks. Cars also got Vortec engines. A great example is the Camaro. Depending on how you optioned your Camaro, it would either come with a 6.2 liter LS3, or it would come with an identical 6.2 liter Vortec L99. They're the same exact engine, they just have two different names for marketing purposes. And so because of that, just for the sake of simplicity, whenever I talk about one of the engines that are part of the Gen 3 or Gen 4 small block Chevy family, I'm just going to call it a LS engine and reference the displacement.
And now back to your regularly scheduled program.
And then when it comes time to service and maintenance your LS, things are still actually pretty easy. At the end of the day, the LS only went out of production up to like 5 to 10 years ago, so it's still really easy to find OEM replacement parts. You can go down to the dealership, or if you want to, you can actually go to pretty much any auto parts store. Obviously, there's all the aftermarket options there, but you can also get OEM replacement parts because AC Delco is owned by GM, and all of the parts that AC Delco makes are actually the parts that GM uses in the factory. But if you're more interested in aftermarket performance parts compared to OEM parts, the LS has an incredibly robust and mature aftermarket modding culture. It doesn't matter if you're looking for basic bolt-ons or you're looking for a complete engine build that will go well into the 1,000 horsepower range. It's really difficult to select an engine that has more tuning potential than the LS. For naturally aspirated builds, adding 100 wheel horsepower is easily doable by just simply swapping out heads, cam, and intake for other easily accessible factory options. And then when it comes to the absolute power potential of an NALS with aftermarket parts, things are pretty unlimited.
When it comes to a solid NA build, the LS and LT is going to be king purely based off how the block design is.
Okay.
Like LSs and LTs have a 120 millimeter bore spacing, which means you can get more cylinder volume out of those blocks versus a Coyote, which is still based on the modular architecture, which is 100 millimeters or 110 or 100 millimeters. So it's a smaller spacing between the bores, so you can only bore it out so much before you start to encroach on the next cylinder.
Right.
So you can bore these LSs out to 4.125, a LS7, 427 cubic inches, 7 liters. Yeah, you do a huge cam, some CMC ported heads, a Holley high ram. You're making 700 wheel horsepower naturally aspirated. You're just not going to touch that with a Coyote.
For boosted builds, very little needs to be done in order to support low to mid-level boost levels, especially with extremely common LM7 due to its lower compression ratio. If you're on a budget and you just want to have big power right now, it's stupid easy to get a cheap turbo setup that will make 600-700 horsepower with very minimal efforts. And if you start to put money into your turbo build and start adding things like pistons, rods, the appropriate camshaft, stuff like that, the LS can easily provide access to quadruple digit horsepower numbers. The LS is also a great candidate for supercharging as well. The LSA supercharger is probably the easiest option since it was a factory OEM part and it bolts straight up to the engines with LS3 style cylinder heads. And if you have the older cathedral port style heads, there's adapters that you can run to do that as well. The aftermarket also comes in clutch for fans of superchargers. There's a whole bunch of solutions out there on the market that allow you to be able to run commonly available superchargers from Ford Cobras, Hellcats, and even the supercharger from the GM 3800. And of course, there are options out there for complete supercharger kits from companies like ProCharger, Magnuson, Whipple, SLP, and way too many companies to name. The crazy thing is that when examining the aftermarket for the LS really suffers from success to the point where the biggest problem with the LS is analysis paralysis because there's just way too many options to choose from. The aftermarket for the LS is so complete that it's actually possible to build an entire LS that has no OEM parts in it. That's just mind-blowing to me. And when it comes time to tune your LS, the factory PCM can be adapted to suit the needs of pretty much most situations that you're going to use an LS for. But if your preference is an aftermarket standalone engine management system, it's no secret that the Holley Terminator dominates the community. But there are options from companies like Haltech, Vitec, HP Tuners, and Microsquirt. And this abundance of aftermarket support is a big reason why the LS provides so much value to your average car enthusiast. Now, when it comes to the value category, I feel like a lot of people misunderstand me and think that what I'm basically just looking at is how cheap this engine is. And that's only part of the equation. And the reason for that is because in reality, in the real world, if you are talking about swapping an engine, it doesn't matter if it's an LS or a Coyote or a Honda K-Series. No engine swap is cheap, and regardless of what people tell you. They're just not cheap. What I'm primarily talking about when I talk about value is two main things. One, the potential cost per horsepower that this engine provides, and two, the experiences that this engine unlocks for your average car guy. When it comes to the dollar per horsepower evaluation, the big advantage of the LS platform is that you can acquire used engines that already have a decent amount of horsepower for a very cheap price. In my area, you can find LSs in the junkyard for a couple $100. Like I said in this video right here, I bought my 6.0 LS for $600. And even if I was just looking at keeping this engine stock, that's like paying $2 per horsepower. You're just not going to be able to beat that. And then when you start to spend money on mods, even if you had the smallest LS of 4.8, you can get up to 450 horsepower naturally aspirated.
We showed up at West Tech Performance with a 355 horsepower, 200,000 mile 4.8 liter LS, and we're leaving with the same LS, but now it makes 474 horsepower. That's almost 100 horsepower per liter, over 100 horsepower that we've gained, and we're within 30 horsepower of the LS7, which was a 500 horsepower, naturally aspirated, 427 cubic inch engine. This is only 293. So if the question is, should I put this in my hot rod? You absolutely should.
From a horsepower per dollar standpoint, there's not really a better engine for a price-conscious car enthusiast. And then when it comes to the experience of ownership, the LS is absolutely invaluable. If you are just getting into the car hobby, and specifically engine modifications, the LS is one of your best options. Typically, when you're working on an engine, there's always this level of fear and anxiety and apprehension as to what's going to be the financial impact of if you mess this thing up. And you're always just kind of thinking in the back of your mind, how much is this going to cost you? And things get worse with the more expensive engines that you work on. But with the LS just being so cheap, you almost kind of don't even have to worry about that. And that level of freedom cannot be understated. If you want to learn how to upgrade pistons and rods, if you want to learn how to swap cylinder heads, if you want to learn how to tune an engine yourself, it's a whole lot easier to decide to do that on your own if you know in the back of your mind that, hey, if this all goes wrong and it blows up, I'll just go down the street to the junkyard and pick up another motor for $300 to $500 and try again. At the moment, there's not really a whole lot of engines that can provide that experience. Obviously, the LS, the Honda K-Series can slide in there. I'm sure there's a few other engines that people will point out in the comments. But at the end of the day, the amount of freedom that the LS gives you in terms of experimentation and just the ability to be able to learn and grow your skills is absolutely essential to the longevity of this hobby. Because let's face it, that's what we need if we want to see the car community continue to grow. We need to have these entry-level experiences where people aren't afraid to work on their own cars, where people aren't afraid to open up an engine and see how it works and make some upgrades. Because the more people that are doing that, the larger the aftermarket grows and the more options that are available to us. And the fact that the LS can provide these types of entry-level experiences is absolutely invaluable. You cannot understate the value that the LS has provided to the car community, regardless of if you have one or not. So where does the LS rank on my is it worth it scale? Well, at the end of the day, the LS is a must-own engine. And I know there's going to be a whole bunch of crusty dudes in the comments complaining because they don't like LSs because
everybody has one.
But that's for a reason. Ultimately, the LS is just a fundamentally good engine. It's a physically small engine with a huge amount of displacement. It's a really simple design and has a galactically large aftermarket. And all of these positives aren't just available for one or two cars here or there, but it's available for literally anyone in the United States that has a couple $100 in their pocket. Yes, there are more technically impressive engines out there. Case in point, the Coyote. The Coyote, in my opinion, is a much more impressive engine from an engineering standpoint. But at the end of the day, that might not matter because the LS is capable of providing experiences that a majority of the car community is actively looking for right now. It doesn't really matter if you're just getting into the car community or you're a seasoned veteran. If you are even remotely interested in engine modifications and you want to have an engine that's going to help you learn and grow your skill set with this hobby, the LS is the perfect candidate for your next project.